Good morning, everyone. I'm Nirmala. I'm working as assistant professor in the Department of Computer Science and Engineering. Today, I'm going to explain about what is meant by this sense of engineering ethics. Ethics is nothing but the basic principle for the public trust in engineering and responsible innovation and social well-being. It is very crucial in this world, relying on the complex technology system with the global infrastructure, which is have spending reaching more than 1.2 trillion annually, and it requires the strength over ethical oversight. What does mean by engineering ethics? There are four concepts which need to keep in mind while we are going for this engineering ethics. First one is the moral principles, next one is the public welfare, professional codes, and beyond technical. In this moral principles, we need to guide all the engineer professional through our code and all our decisions. Public welfare, first we need to ensure the safety of the public welfare and environmental protection. Professional codes, we need to follow the codes which is listed in this NSP, IEEE, and ABT. Next one is the beyond technical. We need to define all the responsible beyond our technical competence. Why ethnic matters, catastrophic consequences. These are the consequences if we miss our ethical principles. First one is the lives lost, environmental damage, ruin, erosion of the trust. The life lost, it result to the direct result of ethical failures. Next one is the environmental damage. It gives a long term ecological impact while we are going for this environmental damage. Ruin, it is nothing but the lost or the money which is involved. Next one is the erosion of the trust. We will be damaging our public opinion and we will be lasting our reputational harm. Ethical failures, so the violations of the soft safety protocols which has led to the core meltdown, 31 immediate deaths and long-term health crisis due to the radiation. So these are the deep water horizon which took place in the year 2010. Negligence risks 11 deaths, around 65 billion cleanup cost, and 4.9 million barrels of spilled into the Gulf of Mexico. So these are the ethical failures which resulted in the high cost. Next one, the core ethical principles of the engineers: public safety and welfare, honesty and integrity, competence, objectivity, environmental responsibility. First one, in this public safety and the welfare, the main duty, we need to ensure all the codes of the NSP, IEEE, Canon 1, and it will be always prioritizing for the good of the public. Next one is the honesty and integrity. It avoids the deceptive acts and upholds the professional reputation and truthfulness in all dealings of engineering. Next one is the competence. We need to practice this only areas which one possesses the expertise, and we need to monitor the continuous professional development. Objectivity. The public statements, we need to consider all our public statements truthfully in order to avoid the conflicts which takes place during the construction, and we need to compromise the professional judgment. Environmental responsibility, sustainable design and responsible resource use. We need to align with the principles of the IEEE code and principle 7. These codes which should be completely followed to avoid the loss. Next one, the case study, the challenge disaster which took place in the year 1986. Ethical dilemma. Nautical engineers warned NASA of a critical O-ring failure which result the about 53 Fahrenheit. Pressure versus judgment. NASA managers overruled the engineering concerns despite the warnings, expert warnings, as well as the critical data and the drive by the launch vehicle. Outcome: the O-ring failure at 36 Fahrenheit, causing the shuttle breakup 73 seconds after launch, tragically killing 7 astronauts. Lesson: prioritizing the schedule over safety leads to the catastrophic consequences, and it will be irreversible to the loss of life. Case study: the Ford Pinto fuel tank in the 1970s. The design flaw: the Ford Pinto's fuel tank was prone to rupture and explosion in rear end collisions, a known design flaw. Cost benefit analysis: Ford calculated around 11 million vehicle per design, around 137 million total, was more expensive than the potential lawsuits, 49.5 million. And ethical lapse: So outcome estimated around 900 burnt deaths and public outrage and the criminal charge against Ford, leading to the product recalls. Lesson: the valuation of the human life versus the corporate profit presents a profound and a challenging dilemma for all the engineers. Next, the ethical challenges which we are facing in the modern engineering: artificial intelligence, data and security, ethical impact, global context. Artificial intelligence, it is algorithmic bias, accountability for all our autonomous systems, and it creates a great complications in our society. Data provide it is providing a vast amount of personal data. It helps in ensuring the ethical use of surveillance technologies. The mitigation and the sustainable resource management, it will be leading to the waste challenges. Next one is the global context. It helps in navigating the cultural differences between people and varying the regulatory standards and the ethical labor practices worldwide. Fostering a ethical engineering culture, education, leadership, whistleblower protection, and professional societies. This education, it helps in integrating the ethics into the ABT and aggregation. It provides a real world case studies and ethical frameworks. Leadership: strong top down commitment to the ethical conduct and clear policies. We are promoting a culture where the ethical considerations are need to be considered. Next one is the whistleblower protection. We need to ensure the safety channels for our reporting concerns without fear, and it should be confidential and fair investigation for all our ethical breaches. Next one is the professional societies. We need to provide the ethical guidelines, resources, and disciplinary actions for all our members who have involved in unethical events. We need to organize the forums for all the discussions and the development activities in ethics. Conclusion: so in we need to build a better future ethically. First one, engineering ethics is non-negotiable for all our progress, and we need to maintain the public trust. Next one, we are upholding the principles while ensuring all our public safety and sustainable innovation for our future generations. So engineer is a custodian for the social well-being and integrity of the profession. The technical decision making should be responsible, safer for our future. That's it. Thank you.